order of a chemical reaction. We have studied that rate of reaction is given by a constant K and the concentration of A raised to the power n. Here n is the order of reaction. In our previous class, we have studied that how to determine this order of reaction by half-life method. Now we shall study that how can we determine this order of chemical reaction by graphical method. Graphical method. See, for graphical method, we have to determine experimentally the concentration of reactant with respect to time. Then we plot a graph. This is number 1, this is number 2, plot a graph between rate versus concentration or concentration of reactant, of course, concentration of reactant, and or this second graph is concentration of reactant versus time. These graphs are plotted with the values of concentration of reactant with respect to time, and by the graph, structure of graph, we can determine what is the order of reaction. Now we shall study that what will be the structure of these graphs in different order. See, first we take zero order reaction. For zero order reaction, the rate is given by K A raised to the power 0. So, here it is 1. So, we can say that rate is equal to constant. So, if we take some values, rate K A and A naught, if we take these values, for simplicity we take value K equal to 1 and concentration as 2, 4, 6. Then what will be A raised to the power 0? It will be 2 raised to the power 0, 1, 4 raised to the power 0, 1, and 6 raised to the power 0, 1. And what will be the rate? Rate is equal to K into this 1, 1 into 1, 1, 1, 1. Now, if we plot a graph between rate and concentration of reactant, then it is 2, 4 and 6, and rate is here 1, rate is 1, 1, 1. At 4, concentration of 4, rate is 1. At concentration 6, the rate is 1. So, it will be a straight line which is parallel to the x axis. So, rate is constant. This is 0 order reaction. Now, we come on to first order reaction. For first order reaction, we know that rate is equal to constant a raised to the power 1. Again, we draw a table taking the values of k and a1, rate k, a and a1. Now, we take again the simple values. For simplicity, we have taken k as equal to 1 and it is 2, 4, 6 again. What will be the a1? 2 raised to the power 1, 2 and 4 raised to the power 1, 4, 6 raised to the power 6. Then what will be the rate? K into a1. 1 into 2, 2, 1 into 4, 4, 1 into 6, 6. Now we draw a graph. This is rate and this is a 2, 4, 6 and rate is also 2, 4, 6, 2, 4, 6. With 2 concentration 2, rate is 2, 4 concentration rate is 4, 6 concentration 6. Then this will be a straight line. This is first order reaction. Now we come on to second order reaction. For second order reaction, we know that rate is equal to constant into a raised to the power 2. Again we draw a table of values, rate, k, a and a square. Let us take the value k a 1 1 and a is 2 4 6, then a square will be 2 square is equal to 4, 4 square is equal to 16 and 6 square is equal to 36. Now rate will be k into a square 4, this into this 16 and this into this 36. Now if we plot a graph, this will be more easier if we take it a bigger graph. Then this is a and this is rate. This is 2 4 6 and with this 2 the rate is 4 16 36, 4 16 36, 2 4 4 16 and 6, then again 36, then it will be like this. This is second order reaction. As the concentration increases, the rate increases with greater amount, greater speed. Rate increase at the greater speed as the concentration increases. This is second order reaction. Now, if we draw the graph between concentration versus time, then we say that this is A and this is time. For zero order reaction, this will be zero order reaction. The concentration of reactant decreases with respect to time. And for first order reaction, first order, the concentration decreases with time. This is the first order reaction. If we take concentration of A reactant versus time graph, and in second order reaction, this is more steep. Second order reaction, this is graph is more steeper. Which means steeper means the value of A, concentration A, decreases rapidly, more rapidly with time. So, this is the with time the concentration of A and this will be more steeper than the first order reaction. So, by determining these structures of graphs, we can determine what order of reaction, chemical reaction is there. So, if we summarize these three graphs, then rate versus concentration graph. This is zero order reaction. This is first order reaction, and this is second order reaction. This is rate versus concentration graph. And if we take concentration versus time graph, then this is zero order reaction, because in zero order the concentration decreases with time by a straight line, because And in first order reaction, this decrease is like this. This is first order, and in second order it is more steeper. This is second order. So, these are the summary of the structure of graphs by which we can determine the order of reaction by after taking the values of A at different time intervals at different times T1, T2, T3, and then we plot a graph between concentration and time, or we can then determine the rate and the rate of reaction and then plot a graph between rate and concentration of reactant, and then by looking at the structure of the graph we can say that what is the order of the reaction. So, this is the method, graphical method by which we can determine the order of the reaction. Thank you for watching the video.